Hello everyone, good afternoon. Good afternoon everyone. Am I audible? Can you see my screen? Yeah, I hope it's fine now. Yeah. Good afternoon and welcome to this session on data science. And good afternoon once again. Thank you for joining this webinar. This 1 hour webinar on data science, where I'll be explaining about the introduction, some terminologies, and what's the workflow, and what's the importance of data analytics in place of data science, why it's required, and a practical implementation. By the end of the session, we'll be doing a simple project, which actually uses data science and data analytics, and it gives us a lot of answers. So we'll be seeing that. So before starting, can we start with the class? Participants, can you please make this session interactive by providing some messages in the chat box? Can we start? Can I get a yes in chat box? Good afternoon all. And please keep the session interactive. We'll go in an interactive way, and finally I'll show you a demo of a project. It's a data science project. How we leverage the skill of machine learning here for the application of data science along with data analytics. We'll be doing that in this. Good afternoon. What about others? Can I get some response? Anyone? Yeah. Thank you for the responses. Thank you. So I think we can start with this. So before starting this, please provide some answers in the chat box. What is data science? What is the definition you could give for data science? Any idea about data science? How will you describe data science in your own way? You could take a minute and write about it. Yeah, thank you for the response, guys. We'll see about data science, and before starting, I need some response from the participants about what is data science. Study of data. Good. Study of data. Yeah. Any other definitions? Simple, short and sweet. You could write some answers about data science. So I like this. Therefore, data science, you could give a number of like introductions or definitions for it. I like this particular sentence. Yes, it is field of study about data, and I personally like this sentence, which is data science is the art of turning raw data into insights. Okay, so it has a lot of parts. Okay, with the help of data analytics, with the help of machine learning and some business intelligence, we can perform this data science. But this is the art of turning raw data into actionable insights. Okay, so with the vast amount of data available today, data science helps make sense of all these data by using statistical and computational methods to extract meaningful insights. Okay, yes, data science is nothing but a science of data using some techniques like data mining and statistic to identify insights. Yeah, you could define in that way. And yeah, so anyway, we have this data nowadays. See guys, data is available everywhere, right? Everything from anything you could collect data with the digital world we are now in, the devices we use, everything collects data. What all actions you do, data is collected. But you guys see that the data is just numbers. That raw numbers, they don't make any sense if you just view it. For example, if you take a data nowadays, the real world data set will look like more like it will be lakhs of rows. What will you do if you just view the data? What can you understand? You can't understand anything or make anything from that. So we are using this art, which is called as data science, which is composed of a lot of tools and steps. It's not easy. It's not, I'm telling you in the base term. With these tools and techniques, what we are trying to do is we are trying to make some analysis Along with that, we are going to make some predictions so that we can find some answers in these data and try to improve the business or any task which you are performing with the help of data science. So data science is the future of decision making too. You guys know data science compose, like it is based on machine learning, with a majority of part is done by machine learning, which provides decision making also. So in today's data driven world, business and organizations kind of rely on data to make informed decisions, and data science play a critical role in this process by providing the tools and methods needed to extract valuable insights from the data. And actually data science is particularly for everyone nowadays. So there is a cliche that this data science has traditionally been used only for technical fields like IT and computer science, statistics and all, but it's becoming increasingly important across all industries and disciplines. Okay, nowadays you take any form of field like chemistry, physics and all these fields are adapting data science, and people who are learning it are also trying to adapt by increasing their skills by learning data science. So anyone can benefit from learning data science skills, whether they are working in healthcare, finance, marketing or any other field. Why? Why guys? Because everywhere we have data and everywhere we could try to improve this. So if this introduction is clear, please post some S in chat box, or if you have any doubts you could post that too. If it's fine, we could continue with applications of data science. We'll see some real world applications and then I'll go into some tools and techniques, how it's done, and the real part of data analytics with a project. Yes? Can others post some answers? Yes or no? Can we continue with this? Yes? Yeah. Okay, fine. So continuing with the next one, applications of data science. I'll show you some commonly used applications which you may have also come across. Disease diagnosis and predictions. So algorithms can be trained on large amount of patient data to identify patterns and predict the likelihood of certain diseases or conditions. For example, the predictive models can be used to identify patient at high risk of developing diabetes, heart disease or other conditions. This can be predicted. Predictive analysis, like with the help of data science and time series forecasting, you could use to predict various financial outcomes such as stock prices, interest rates and economic indicators, and this can help financial institutions make more informed decisions about investments and other financial activities. And in pharmaceutical industries, like I don't know how many of you guys heard about these particular applications like drug discovery and development, data science techniques can be used to analyze large data sets and identify new drug targets or potential therapies, whereas these data science models can also be used to predict the efficacy and safety of drugs before they are tested clinical trials. Okay, in clinical trials, before going into trials, so when you take the procedure to follow in the clinical trials, there are a lot of steps involved, guys. So this medicine and all, they would have discovered it years back. Okay, so for example, if you discover or if you synthesize a medicine, if you want to commercialize it, it takes years. Okay, more than 5 to 10 years it takes. Why? Because they need to conduct a series of steps to be followed. So there are, for example, if you check the site of FDA and all, okay, from USA, Food and Drug Administration. So what they'll used to do is they'll test it step by step into different, like for example, animals, and then step by step they'll bring it into first test case for humans, and when it comes out, it takes a lot of time. But if you have some data before doing this clinical trials, we could also perform a prediction, and it may helps us to reduce the time which is consumed for elongated process, right? So that's one of the application. And customer segmentation and targeting data science techniques can be used to segment customers based on their behavior, preferences such as which product they are likely to purchase, which marketing message they are likely to respond to. So which is good, A bar B testing, they can go with that. And this can help marketers develop more targeted and personalized marketing campaigns. And in social media and all, they used to analyze our data and based on your preference. For example, in Instagram, if you consider Instagram, Okay, all your data is stored and that algorithm is giving you the suggestions, right? The feeds and all is generated by the algorithm. So they uses data science. Why? Because they want you to spend more time in their application, so that increases their revenue. Okay, to do that they prefer, like, they find with the help of data and data science, they find what you may like. Okay, some group of people, if they like this, if they suggest these things, that could be really better, and you spend more time. So there also some kind of data science is applied there. Then crop yield prediction. Data science can be used to analyze historical crop data, yield, and predict future yields based on various factors such as weather patterns, soil conditions, and irrigation practices. And this can help farmers better plan their operations and make more informed decisions about crop selection and planting schedules and so on. If these applications are clear, please post down yes or no, any doubts. If it's fine, we could move into tools which is required for data science, what is the workflow of data science and so on. Yes guys, is it clear till now regarding the introduction, and we have seen the application of data science. Now we are going to discuss about tools for data science. Okay, I'll be telling you a high overview, okay, because this is a 1 hour session. I can't go in depth and explain you all the tools one by one. I'll be going a high level overview. Try to grasp these things, and if you are interested, you could check our site and YouTube channel. We have a lot of in-depth contents also, so it's up to you. If you are interested, you could search and learn more. So we'll start with tools for data science. So particularly if I tell you the tools which is required for data science, mostly Python programming and R programming. Like, I personally prefer Python programming. R programming is also involved, so you could choose any of these two. And you need to have some data analytics skill. That's where the data visualization comes in. So if you talk about Python programming libraries, we have Matplotlib, Seaborn, SciPy and all. So these library and all, they provide extensive and nice graphs which you can generate and save. Okay, you also have interactive graphs like Plotly and all will give you interactive graphs. Along with that, you have some business intelligence tools nowadays like Power BI, Tableau. If you go into AWS, you have QuickSight. These are some of the business intelligence tools, right? So using these tools, what you could do is you could create visualizations. So the thing is, when I talk about data analytics, I'll tell you guys, data visualization is the art of storytelling with the data. Okay, when you see the raw data, you can't understand anything, but if you present it in charts, nice charts and graphs, it will tell a story, guys. So that is important, because only when you understand what is your data, what is there in your data, then only you can proceed with the data science. Without knowing that, there is no use. And talking about the next step, which is machine learning. Machine learning is nothing but, if you have your data, you will be doing analysis and pre-processing and training an algorithm which will give you prediction. So this task comes under machine learning. So we'll be seeing some elaborative introduction for machine learning and all. So that will help you to make future predictions. And you also have NLP, which is natural language processing, and this is particularly for text data. Human language data, natural language data comes under natural language processing. And some advanced version of machine learning is deep learning. We have deep learning, and a lot of mathematics and statistics is involved in these algorithms, data analytics and pre-processing parts. Statistics plays a huge role. So these are the tools for machine learning, tools for data science. I hope the Python programming is for building all these things. Libraries is available in Python. Data visualization, you could do Power BI, Tableau, or you could also leverage Python libraries to do it. We'll see about machine learning, NLP, deep learning and all, and statistics are involved in algorithm creation, and everything revolves around maths and statistics here. So what is this machine learning is? It is the creation of algorithms and models which are capable of making informed choices or decisions by processing the data and learning from it. Okay, so this is what machine learning is. Okay, so it's literally the machine learns. The machine means my algorithm, it means my computer. So the data which I have, okay, I can't directly give it to my algorithm. Okay, this data which you will be collecting from your sources or open source or some forms, etc., or you could manually do it. These data may or may not be correct and accurate. So to understand this, Yes, to talk about best Power BI or Tableau, you like they have both of their advantage and disadvantage. So companies nowadays require option of both. Either you have to like they require knowledge of Power BI and Tableau nowadays in the recruitment and all. I would suggest learn one thing better, Power BI or Tableau. Learn one very thoroughly, in depth, and the another one you could start learning over the time. You will be pro in both. The concept is same anyway. The tool and the UI changes. Okay, the user interface changes anyway. But if you have the general idea of data, so for example, you should have the understanding of when you should go for a line graph. Okay, when you should go for a bar chart, when you should go for a pie chart. Okay, so all this understanding will make you a better data analyst, because you are going to anyway Power BI and Tableau, you are just going to create dashboard and charts, but what is the content inside, that's from your mind. Okay, it's same if you could do it with Python. Anywhere the content is same, only the UI changes. So yeah, for you could take that. Yeah, so we have the data, we'll analyze and process it, and then we are giving it to our machine learning algorithm. So this algorithm is nothing but a statistical tool which tells like what is the task you have learned it will give that particular answer. Okay, and particularly what is deep learning is, it is an advanced version of machine learning. It's a specialized field where artificial neural networks are employed to process and analyze this data. So here the same task, instead of this predefined algorithms we use in machine learning, we have some advanced version which is neural network, which is composed of neurons, which is created to mimic our human brain. Neurons, neural network, the concept of our human brain, to mimic our human brain, they have created this. And yeah, when we talk about machine learning, deep learning and all, NLP, all these tools also proceed towards AI. Okay, because machine learning can give you predictions and answers. It is one of the decision making tool, and they all are tools which is used towards AI, not only for data science, for AI also they contribute. And yeah, we also have to discuss about this NLP, which is called as natural language processing. So this NLP, right? So this NLP is a collaboration of human language, artificial intelligence and computer science. So why this is? Because particularly when we have data which is text, okay, once again your neural network or your algorithm, they are statistical tools, they can just work with numbers. Okay, so if you have any data, if it's image, you could do image processing, convert image into numbers, into matrix format by pixel values. If you have text data using NLP tools, we have certain libraries, NLTK, Spacey and all, which will help you to convert these texts into some meaningful numbers, so that you can give it once again to your algorithm or neural network and proceed with the same thing. ChatGPT and all, they use this NLP. And yeah, talking about NLP, NLP is a machine learning technology that gives computers the ability to interpret, manipulate and comprehend human language. So if these things are clear, we could go into some of the contents of machine learning and tools and procedures to follow. And before that, I just want to show you guys about the types of machine learning. We'll come back once again. Talking about machine learning, it's one of the important part of data science. You can perform data analytics, and the data science can be done only with the help of machine learning. So the types of machine learning, we have supervised learning, where for example if you have a data, okay, and you will be having labels, means it's supervised learning. Labels means, for example, these are the shapes and these are their respective labels. If this is that circle, if this is the shape, it's square, if this is the shape, it's triangle. And if you just load these things to train your model, okay, so the algorithm is learning now, if this is the shape, it's circle, if this is it's square, if this is it's triangle, then it will going to make prediction. So when you give a new data, it will give that this is circle, right? So this is supervised learning. You are giving labeled data. And in supervised learning, we have two types. One is called as classification, another one is regression. What we have seen here is called as classification. The task of this algorithm is to learn these and finally classify either the output is belonging to circle or square or triangle, or it could be something like yes or no, cold or hot, something like these things comes under classification. Okay, whereas you have something known as regression. So what does this regression means? It is the part where you are going to predict a continuous value, like a stock value, or like what's the temperature value. Okay, for example, if the temperature you are going to predict is cold or hot, that is classification, whereas you are going to predict the temperature is which particular value, that comes under regression. It's a continuous value. Okay, and when we talk about unsupervised learning, we have unlabeled data, which means the task of this machine learning algorithm in unsupervised learning is to find similar groups together. For example, these two guys look same, these two have similar features, these two have similar features, and these three have similar features. So the task of this unsupervised learning algorithm is to find and categorize them. It is used in mall dataset or customer segregation dataset to find it together peoples. Okay, so that personalized campaigns, marketing campaigns can be done for them particularly. Okay, what are the designations in data science profile? Okay, you could be a data scientist, and before that it would be good if you are a data analyst, if you have some experience or data analyst, or if you have some experience on machine learning. It will be a good profile for you to move further on data science. So these are the important things anyway. So, and statistics also is required. And in machine learning we have one advanced type. It's a entirely new field and in-depth field, advanced field, reinforcement learning, where it is used in games and all, where we have a agent and we have an environment, and the task of it will be doing an action, and based on that action, if it does that correctly, it will be getting a reward. If the value, like if it's successful, the reward will be high. And if the action goes, like if it's like, for example, if the action is good, then it will be giving a high reward. So what it does is it understands that this is the best action and proceed with that. If it done something wrong, what will happen is the reward will be less, so that it will try to improve, and eventually over time it will be working good. And once again, machine learning is the important part here, right? So what is the steps involved in machine learning is, first, in data science also you need to collect your data somehow. Okay, it could be from open source or any from where you could collect also. So these data which you have, right, you have to mandatory perform something called as pre-processing, because you don't know how your data will look. Okay, you need to analyze it and then do some pre-processing. So once it is done, we will be going into train test split, where we will be splitting our data into training part and testing part, and we will be doing some feature selection, model selection, and trading, prediction and evaluation, and so on. So as a student or as in the open source, you could have these sites. For example, you have Kaggle, you have UCI machine learning repository, and you also have Google dataset search. So these are some of the common sites where you could download datasets. Anyone used it before? Can you post some answers in chat box? Anyone tried this before? Kaggle and all, most of you people have tried it. And GitHub also is a good open source for you to search datasets, right? And so once you collect your data mostly it will be in CSV format, comma separated value format. So when you have your data, you could perform some pre-processing, which is commonly done, like feature scaling, encoding can be done, null values can be imputed, and outliers can be detected and handled, because these things will pull our output down. Okay, so for feature scaling you could use Python library like sklearn. And why and what's the reason of feature scaling is, it is a method to normalize the range of features in your data. So it involves process like normalization or standardization, and it helps to avoid bias in machine learning model. And the reason behind this is, for example, imagine you have a data set with features like age in a column, weight in a column, and length in a column. Okay, so age and all you will be having from the range will be 1 digit to 2 digit, maximum 3. Weight mostly in 2 digit, and length mostly in 2 to 3 digit, right, in centimeters. So when you have these data of different range, when you train your algorithm, what happens is your machine learning model can put weight on one particular thing, like which is length, because it's a larger scale. So to avoid these things, to help everyone equally contribute, we could perform scaling, where we can go for normalization, where what I'll be doing is the particularly new value of that particular place will be that value, old value minus minimum value of that column, divided by maximum value minus minimum value of that particular column. And when I do this, my data all in that particular column will be between 0 to 1. Why? Because I'll find the lowest value. Okay, so in this particular column the lowest value is 2. So if I apply this formula, it's 2 minus minimum value is 2 divided by what's the maximum value? 12 divided by 2. Okay, so what will happen? This will become 0 actually, so the entire thing becomes 0. So now this will be replaced into 0. So my minimum value is 0 here, and if I have a maximum value of 12, if I find for this value, it's 12 minus 2 divided by 12 minus 2, which will be 1. Okay, it will be 1. So now my maximum value is 1. So all these values which are between these will be in the range between 0 to 1. It will be decimal values between like 0.1, 0.2, something like that. So if I do this for all the columns, that's normalization, so that everything will be between 0 to 1. Or you could perform this with sklearn.preprocessing. You could import min-max scalar and do this. And you could also perform standardization, which the output, if you apply this formula, the output will have a mean value of 0 and standard deviation of 1, like normal distribution. You could use standard scalar for this. And if you have outliers, okay, in your data, if you have a lot of outliers, you could perform robust scalar, which uses quartile range and give more importance to the range between Q3 and Q1, and the outliers are given less importance. And when your data doesn't follow normal distribution, you can go for normalization. When your data follows Gaussian distribution, you could use standardization. And when your data has outliers, you could use robust scalar. And as you guys know, my algorithm can work only with numerical values. So if I have text values, I could perform encoding. Like we have two types, one is nominal encoding, another one is ordinal encoding. So for example, if I am having features like red, blue, green and blue and something like that, 3 different features are here. If I perform one hot encoding, it will turn them into binary format. So if I have 3 different classes, 3 columns will be created, and 1 means that particular thing is present there. So here it's red, so it's 1 0 0. Here it's blue, so it's 0 1 0. Here it's green, it's 0 0 1. Okay, like that the features will be encoded in one hot encoder. And we have label encoder, which is from sklearn preprocessing. So this guy will allocate, for example, A, B and C. It will give some hierarchy level, like A, let it be 0, B will be represented as 1, C will be represented as 2. So you could use both of these, so to turn them into numbers. And train test split is a part where, for example, in machine learning, what's the idea is, if I am having 10,000 rows, I will be splitting them into parts. For example, this test size of 0.2 is 20%. I'll split 8,000 rows for training and random 2,000 rows for testing. Okay, where I'll train my model, and to evaluate its performance, I'll go for testing in this 2,000 remaining rows. So that is done in train test split. And also you could directly jump into model training after this train test split, or else you could perform this feature selection. So what is this features and what is this target is? I want to show this slide. Okay, so for example, in my machine learning or data set, okay, there will be a target. It could be your label, like the circle, square or triangle, or the temperature you are going to predict, the diabetes, yes or no. These are the features, like what's their pregnancy level, what's the glucose level, what's the BP and all. So these are called as features and these are target, and we are trying to find their relation so that statistics can be done and try to find the output. Okay, so these features, you may have lot of features. If there are lot of features, then your algorithm can be confused, and it's better to go with minimal important features. So that is called as feature selection. So it is the process of reducing the number of input variables when developing a predictive model, and it is desirable to reduce the number of input variables to both reduce computational cost as well as to reduce model and get rid of noise. So for feature selection, we have some statistical methods like dropping constant feature, correlation method, mutual information test, chi-square test, and ANOVA F-value test. And you could also perform these with scikit-learn. Feature selection, you have mutual info classifier for regression, for classification. You could also use this select k-best, and that will help you to find the best values. You could get it from get support. And yeah, so these are some of the tests. And particularly once you finish this, you could come into algorithms. So for algorithms, you have to consider the nature of the problem you are going to solve, which type it is, classification or regression, supervised or unsupervised learning. Nature of the algorithm also you have to know, and performance comparison to evaluate it. So these are some of the algorithms which you have in machine learning. You have for supervised learning, we have classification and regression. For classification, we have some set of algorithms, and for regression, we have some set of algorithms which is available. Okay, and these are some algorithms which some algorithms play both role, like decision tree classifier and decision tree regressor and so on. And yeah, so finally, with all these introductions, terminologies, we are going to use data analytics and data science skill to predict this telecom customer churn prediction. It's a data set from a telecom company. Okay, so churn means prediction in a common case in machine learning. If you are not familiar in that term, churn means leaving the company. Okay, it is a critical for business to have an idea about why and when customers are likely to churn, and having a robust and accurate churn prediction model helps business to take actions to prevent customers from leaving their company, right? So can we see this project, guys? Can we see this project hands-on? Can I get some response in chat box? Can we see this? Yes, fine. So I have it here. So I'm going to use Google Colab for this task. I'll upload the data set here. I have this churn data, and these are all the features I have in my data set. I have customer ID, their gender, senior citizen or not, partner. 1 means senior citizen, 0 means no. Whether they are partners or not, they are dependents or not, what's their tenure, what's their phone service, multiple lines they have or not, internet service, whether they are opting for or not, online security, online backup, device protection, tech support, streaming TV, streaming movies, contract, paperless billing method, and monthly charges, total charges, and finally we have a column target or label which is churn, which means they have churned the company or not. Okay, so we'll wait for this data to load so that we can kickstart with it. Can you please more specific on the deployment part of data science? I can't understand your question. What kind of deployment tools available for data science? Deployment means you are going to deploy your algorithm. You could use cloud tools like MLOps with AWS and all can be done. AWS or Azure, you could deploy your model, endpoint there to make predictions lively and maintain it, continuously integrate and deploy it. You could do it with CI/CD tools from cloud, or GitHub Actions can also be utilized. I am taking the necessary libraries like Pandas to work with data, NumPy for numerical tasks, Seaborn and Matplotlib for visualization. And I am loading my data here using Python, Pandas, and this is how the data will look like. Okay, we have this data of customer ID, their gender, senior citizen or not, partners or not, dependents have or not, Okay, like that we have all the columns, and finally we have churn, which means yes or no. Okay, so as you guys know, customer ID can't be making any prediction, it's unnecessary here. So unnecessary columns I'll be dropping it. This is the data we have finally without that, and I'll go and get an info about the data types. So it seems like there are no null values, so we need to check that too. And I'm getting the column names, and let us get the target variable, which is churn value counts. So in my data set, from that 7000 data, okay, the total shape of it is nearly 7043. In that, 5100 people has stayed in that company, and nearly 2000 people has left the company. So you could view it in the visualization also. From this is nice, right? So instead of these things, churn yes, churn no, you could see how many. Okay, I'm doing it with Seaborn. And you also have, we could see that there is an imbalance in this target variable, right? In this target variable there is an imbalance, because in machine learning it's better to go with a balanced data set. You can keep it in your mind later on. If the model performance is not good, you have to perform sampling methods. Okay, and scrolling below, I'll select the categorical features. Here categorical means yes or no, male, female and all, they comes under categorical one. And for continuous values, the range of values, like what's the price, okay, something like these things, or charges or continuous values. So I'm going to use a for loop, and I'm going to do a count plot to get a count of all these categorical features. So let me get and run this. So it will give me this nice visuals of gender. What we could see is gender, the count in my data set is equal, both male and female are nearly equal. Nearly 3500 people are there, totally 7000, right? And senior citizen, what I could see is senior citizen, yes, one means yes, they are very less. Senior citizens is around 1000, remaining 6000 is they are not senior citizen, young peoples. Partner, we could see yes and no is somewhat equal, no is high. Dependents, yes or no, yes is less, no is high. Phone service, okay, most people have selected the phone service. Okay, it's a telecom company, and few people have no in it. And the multiple lines, whether if they don't have phone service, we can't count that, right? So if multiple lines they have got or not, no is high. Internet service, the same way we could see. And online security, whether they have obtained or not, no is high. Most people don't prefer online security and all. Online backup, many people haven't, yes is less. Device protection, no one, most people, more than 3000 don't have it. Tech support, most people don't bother it. And streaming TV, nearly we have yes and no. And if they don't have internet service, all of these things are not coming. Okay, it's belong to that internet service. Okay, and finally the contract, how much type it is. Month to month contract is high, 1 year contract is less, 2 year contract is less. Paperless billing, whether they are opting for paperless billing or not. And what's the payment method? Electronic check, people prefer electronic check more. And all of these remaining things are nearly equal. And I'll also visualize this part of senior citizens, we'll show it. So this is giving me in senior citizen, if it is what's their thing and they were churned or not, what's their particular count. Okay, senior citizen no means their customers are 4500. We have seen it in the chart. Okay, they are not senior citizen but they have churned, they are 1300. They are senior citizen, they have not churned is 666, and they are senior citizen, they have churned is nearly half of them have churned from this. Could you see it? Okay, that's a percentage we are calculating. The percentage you could see from that overall. Okay, nearly half of them have churned, and I'll show it in a bar plot too. So this is what you can use hue to get this nice visual. From this I could see all of these details. 0 means they are not a senior citizen, and you could see how many people have churned in this, very less. Yes. In senior citizen, the people, nearly half of them have churned. That's the data we could understand. So senior citizen have high churn rate of nearly 42% than non-senior citizens. Okay, and then for partners and dependents, okay, customers, they don't have partners, dependents are more likely to churn. If they have partners and dependents, they, from this data, they are not churning. And phone service, customers with multiple phone lines, okay, have high rate of churn. Yes means they nearly this much they are churning. Okay, and then internet service. Okay, so then, yeah, 1 minute in this. So we'll see this additional services which we have, this 6 additional services we have. So in that, if you could see, we can see online security, online backup, device protection, tech support, streaming TV and streaming movies, and whether they have opted for this service or not are shown here. And we'll see now the churn count. Okay, so the number of churn we have in this side, and we could see that customer with these first 4 things are unlikely to churn. Okay, red is very less. And yeah, so we'll see the next things like contract and payment. So we could see that month to month contract means they are most likely to churn, because every month they may change and they like think like anyway, so they leave the company. That's more high here. But when you go for 1 year or 2 year contract, okay, so the people more likely to stay. So this is one thing. So what this company has to do is they try to convert their customers from month to month to a long term contract, means the customer will stay. And yeah, observation of a payment method, okay, in these, and the gender and gender churn, we could see they are nearly equal in both. So gender is not a deciding factor here. And the numerical features, we'll select that and do a plot with KDE plot. This is the tenure and whether they have churned or not. Okay, total charges, and finally the observation for the tenure with the monthly charges and tenure with the total charges. Okay, this is tenure and the monthly charges, and we could see a trend here. When the total tenure increases, total charges also increases, we could see at, and their churn count you could see no is high and yes is also there. And we'll go into now, this is all the data analytics part to understand your data and what happens there. And finally we are going into the pre-processing, where I'll perform scaling using min-max scaler and turning the numerical features. And also you could see there are a lot of yes, no and details like that. So I should go with label encoder, okay, turning the categorical features into encoded one, and this is what they are mapped one. Female is 0, male is 1, senior citizen, that's fine. Partner no means given 0, yes means given 1. Like that I have turned them into encoded one. Okay, also yes and no in the target we'll turn it. And I'm going for train test split, where I'm splitting them into parts. So this 7,000, from that I'm taking 70%, which is for like nearly 5,000 for training, and remaining 30%, 2,000 rows for testing. And I'm going to perform the feature selection using f_classif f1/test, and I've selected the best 6 features out of it, which is these features, to train your model and get prediction. So I'm going to first use a algorithm which is decision tree classifier, and I am training and getting a score of 73%. And there is a problem here because I haven't performed the scaling. In the start itself you could see there is an imbalance. You could either go for overscaling or oversampling or undersampling. Sampling needs to be done, so it will improve your accuracy and model performance. I'll show with example, which other examples, like there is a heat map of 0 correctly predicted as 0 and 1 correctly predicted as 1. 1 is wrongly predicted more than half. Okay, the model is not performing well in 1. So we need to perform sampling to improve its performance. So this performs really good, 76%. Yeah, this one count has increases more here. and also support vector machine. So you could use these algorithms, or you could also leverage the skill of neural networks. Anyway, in pre-processing we need to proceed with furthermore machine learning concepts so that it will perform well. And finally, once this, for example, we'll make predictions like this, for example, and we'll go into a part of building a predictive system, so that in future, if this company wants to predict, if they have a new set of customers, they want to know how many people are most likely to churn, they'll use this algorithm, and they'll take these features, and for example, if I enter the value, what's the tenure? 1. Okay, I'll enter some values here, 0, 1s and all the values. So if they enter their particular details, what this should do is, okay, it should give me a prediction finally. So these inputs, if I ask it to my algorithm to predict yes or no, so it is going to give me the chances is yes or no based on the training happened. So once the model performs well, they can give accurate results, and the idea behind is they will be performing well in this prediction, so that company can get some idea about which customers are most likely to churn, and if they found that most customers are likely to churn, they could do some promotional activities or some marketing campaigns, some personalized campaigns to improve their company churn rate, to reduce their company churn rate. They could perform it. So this is how the data analytics and data science are helping in the real world for business, and they have a lot of applications and lot of more steps and processes are involved. I have tried to give you a high level overview in this session. So that's it. Thank you. Thanks for attending this session. And make sure you are filling the attendance link, and I hope you got a review link. If you got a review link, please post your reviews there. It will be really good if you post a review in that link about how this session went. Anyway, thank you. Thanks for attending this session. We'll see you in some other webinar. Okay, talking about EDA, we will be performing exploratory data analysis, like we have explored the data set, and then we will go into pre-processing, then model training, feature selection, model training. When you train your model, you could also perform hyperparameter optimization, training multiple algorithms and then testing it, evaluating. That's what the performance analysis is. You could perform classification report or confusion matrix, get the accuracy score and all, and try to find which algorithm is good. So once you find which algorithm performs better, you could take it for your next step for future predictions and all. Thank you for your comments. Well, that's it guys, thank you.